So in this video we're going to see how to solve simultaneous equations by Cramer's rule, and the next one is Gauss elimination method. This video will be helpful in network theory subject or circuit analysis, whatever it may be. We will see this by a problem. Example, solve. Solve means what? Here we have three simultaneous equations with three unknowns. We have to find I1, I2, I3. Solve means we have to find usually x, y, z, but here it is I1, I2, I3. So first method by Cramer's rule. How to proceed? Listen carefully. First one, we have to find the determinant of the coefficients of this. What are the coefficients? 5, minus 2, minus 3, minus 2, 4, minus 1, minus 3, minus 1, and 6. You know how to find the determinant. Okay, 5 into the small minor, minus of minus 2 into minus 2, minus 1, minus 3, and 6, and minus 3 into minus 2, 4, minus 3, 1. Simplify and get the answer for the determinant. Next, we have to find I1. In Cramer's rule, I1 is found out by d1 by the determinant. d1 is nothing but we have to replace the first column by this one, the right side of the equations, 10, 0, 0, and then find the determinant, that is d1. 1 means the first column replaced by these numbers. So 10, 0, 0, the rest divided by the determinant already found out, it is 43. Now how to find the determinant? As usual, 10 into this into this minus this into this, minus of minus, which will be plus 2. It will be 0, minus 3 into this also will be 0. Divided by the determinant and get the answer as 230 by 43. Simple multiplication. Here. Next is I2 is what? d2 by d. That means what? Replace the second column by 10, 0, 0, and then find the determinant. That gives you d2. And then divide by 43, you'll get the answer as 150 by 43. Similarly, find I3, which is d3 by determinant. I3 is what? d3 by determinant. Replace the third column by 10, 0, 0. Find the answer as 140 by 43. This is how we have to solve to get I1, I2, I3 by Cramer's rule. Next is Gauss elimination method, a new method. First we'll see the method, then we'll proceed with the same problem. It is a systematic way of eliminating variables which is called triangularization. So we have 3 cross 3 matrix, right? 3 cross 3 matrix. We have to eliminate the variables. That is, we have to get zeros here. The first, where and all you have empty box, that means it is 0. How it is done, we'll see with the problem. Reduction to triangular form, and finally we'll get I1, I2, I3. Spaces without an x, it has a 0 in them. Okay, how to get 0 we will see. Back substitution. The same problem, how to eliminate the variables. The idea behind this Gauss elimination method is we have to eliminate the variables. So when you take the first two equations, here we are going to eliminate I1. How? Usually we will multiply the first equation by 2, the second equation by 5, and so on. Here multiply equation by 2 by 5, the whole equation. So 2 by 5, when you multiply, this will becomes 5 and 5 will get cancelled, get 2I1 minus 4 by 5I2 minus 6 by 5I3 is equal to 4. 10 into 2 by 5 is what? 20 by 5, which is 4. And then we have to add the first and the second, this equation and the second equation. When you add it, this will get cancelled. Simplification, you know, we are not subtracting, we are adding. This plus will be retained as plus only. Okay, and write it as equation 4. Next, multiply equation 1 by 3 by 5. and then we have to add first and the third equation. When you multiply this 3 by 5 means what? 5 will get cancelled, we get 3i1. We are now concerned with 1 and 3. First we are concerned with 1 and 2. Now 1 and 3. When you do that, again the first terms will get cancelled. We are adding and then simplify and get and write it as equation number 5. Now we have two variables, two equations, 4 and 5 with two unknowns. Multiply equation 4 by 11 by 16. Multiply equation 4 by 11 by 16. What will happen? 16 will get cancelled. We'll get 11 by 5. Now the idea, first we have removed I1. Next we are going to remove I2. That is elimination of variables. So multiply by 11 by 16. And then add the equations 4 and 5. Okay, 4 and 5 equations. When you add it, you'll have I2 will get eliminated. You'll have only I3. I3 when you simplify, you get it as 140 by 43, which is the same answer using Cramer's rule. Then substitute this I3 in the fourth equation and then find I2. Then substitute I2 and I3 in the first equation and find I1. Simple method. This is mainly used when you have the order of the determinant becomes larger than 4 or 5. This Gauss elimination method is advantageous than Cramer's rule. So wonderful method. Okay, try it and see. Same problem and similar problems you can work it out. Okay, all the best.